All right. We're going to use algebra to solve this equation from 0 to 2 pi. Notice that the word here, we've been doing proofs for so long, this says solve, not prove. If you tried to prove this, it's not possible. So where a proof works for any value, a solving question, you're trying to find the specific values that it works for. So for part A, why is it doing that? Anyways, so for part A, when we're solving this, right now, can you see that it has two trig functions in it? It has sine of x and it has cosecant of x. And it's going to be very hard to solve this if you're dealing with both of those. So we have our identities and we say to ourselves, is there a way that I could change this equation so I have only one trig function? What could I change? I could change my cosecant to 1 over sine. There we go. If I change my cosecant to 1 over sine, what we've done is we've changed our equation to have only one trig function. Now you have to use your algebra skills from all your algebra units that you've done up till now. How do we solve this kind of equation? Okay? What would you suggest doing next? Get this other sign to this side? Is that what you said? Or what? Okay, so how would we go about doing that? You want to subtract this to this side? So those ones are both. So if we subtract that 2 over sine x to that side, we have this equation. Now, one of the things you can do as far as looking at this equation and trying to figure out what you should do is think back, well, if instead of sine I just had x's, what would this look like? So off to the side here, if I just had 2x minus 2 over x equals 3, because that's just replacing the sine x with x. How do you solve that kind of a question? Do we know what kind of function this is or what kind of equation this is? This is called a rational equation because you have x's on the bottom. And we did rational equations in grade 11. How did we solve them? What did we do? Well, one of the things that we did was we tried to get rid of that fraction. Because if you have that fraction, it makes it difficult. So if I could get rid of that x on the bottom, maybe this equation would become easier to solve. How do we get rid of that x on the bottom? Multiply by x, right? And if you multiply one side of the equation by x, you multiply the other side of the equation by x. Now, when multiplying, if I multiply this by x, why do I multiply both of these by x? Doesn't it feel like I did more on one side than the other? Because the rules are for equations, what you do to one side of the equation, you do to the other side of the equation. But why is it that in this one, I'd multiply two things by x on one side and only one thing on the other? Okay? So technically, what we're doing here, because this is a binomial, is when I multiply this whole side by x, that x would get distributed to this one and to that one. So that's why we multiply each term by x. Because if you multiplied that whole side by x, both of those terms would get multiplied by x. So in our equation, now we can sort of, this was just an aside to help us remind us of what we've done in the past. Now with our equation, what do we want to get rid of? We want to get rid of the sine x on the bottom. So we would multiply everything by sine x. This term by sine x, this term by sine x. What will that do? Here, your sine x's will cancel out. And you'll get 2 sine squared x minus 2 equals 3 sine x. And now we recognize that it's a quadratic equation. So we have to use our algebra skills from rational equations. And once we change it out of a rational equation, it becomes a quadratic equation. So we now have to use our algebra skills for solving quadratic equations. And that would be make one side equal to 0 and factor. Now this one's fairly easy to factor. For 2 sine squared, the only thing that would give you 2 sine squared for our first terms would be 2 sine x and sine x. Now the only thing that gives us 2 for our last term is 2 times 1, but it will make a difference where we put the 2 and where we put the 1. Remember, we want our outside and our inside values to make -3, or to make 3. So can you see that if you put the 2 in the first set of brackets and the 1 at the end, your outside would be 2, your inside would be 2. 2 and 2 never make 3. But if you put your 2 on the outside and your 1 on the inside, can you see that your outside makes 4 and your inside 1? And 4 and 1, if they're subtracted, will make 3. Now we need a -3. So we would want to make our 4 negative and our 1 positive. Now that we've factored this, this means that sine x could equal -1/2, or sine x could equal 2. Is 1/2 on your pie plate? What family? Pi over 6. What quadrants? 3 and 4. So we'd have 7 pi over 6 and 11 pi over 6. Is 2 on your pie plate? No. Can you do that one without your calculator? So we need our calculator for the second part to find our reference angle. So take out your calculator and tell me what it says. It'll tell you not possible, right? It'll give you an error. So you could do this one without your calculator. How do we know it's not possible? Because it's bigger than 1, right? If you change this to a fraction and you think sine is opposite over hypotenuse, is it possible to have the opposite side 2 and the hypotenuse only 1? No, because the hypotenuse has to be the longest side. The last thing we always need to do in these questions, because we will naturally, we've done so many that we naturally solve between 0 and 2 pi, we should check the domain. And if I go back to the beginning, what's the domain? It is 0 to 2 pi, so we're good. But sometimes you'll go back and it'll say, oh, from -pi over 2 to pi over 2, and then you'll have to adjust some of your answers depending on the domain. All right, for the second one here. Part B, sine x equals cos x. Did that work? No, there we go. Sine x equals cos x. Well, some students will solve this one by just thinking about your pi plate. Is sine ever equal to cos? Pi over 4. Anywhere else? Because at pi over 4, you've got root 2 over 2, comma root 2 over 2. And 5 pi over 4. In quadrant 3, they'll both be negative. So this question could be solved that way. You just know from your pi plate where sine is equal to cos. Okay? We can also use the strategy we used in that first one. The strategy in the first one was, if we can get our equation just in one trig function, then probably we can solve this. So in this one, if I divide both sides by cos, I'll get this. Can you see a way that I can change this so that it's only one trig function? Sine x over cos x is tan. And so if we had tan x equals 1, is that on our pi plate? Yes. What family? pi over 4. What quadrants? Quadrant 1 and quadrant 3. And you would get those two answers again. So those are two different ways that you could solve that one. Question number 10 is one for practice.